Hi, my name is Jeff Hilland. I'm president of the DMTF and a distinguished technologist with Hewlett Packard Enterprise. I'm going to be presenting today on the Redfish ecosystem for storage. We've been working on this for quite a while and really happy with the result that we've gotten so far. Just a quick disclaimer that what you're seeing today is a snapshot of the work in progress from both DMTF and SNIA. It's subject to change without notice, and so pay attention to releases from the organizations to make sure you stay up to date with the latest information. I'll be going over a little bit of background for the DMTF, who we are and what we do, and then get into the background of Redfish, just the general structure of how Redfish is organized, then dive into local storage, some of the fabric model for networking that's needed for things like NVMe-OF, and then get into Redfish device enablement briefly, which is how you can populate this information in a BMC with local providers. So DMTF is an industry standard organization. We're led by the who's who of management, innovative industry leading companies. The DMTF has a local and global presence with members in multiple countries across the globe. We support a diverse, emerging and traditional IT infrastructure environment, including cloud, virtualization, network, servers, storage, inside the box, outside the box. There's a complete list of standards in the DMTF website. We've got specifications that are adopted and accepted by ANSI and ISO. We're one of, I think, 9 past submitters or organizations that can take their specifications directly to ISO. And we've been working a lot lately on the simultaneous development of open source and open standards. We don't believe it's one or the other. Both can make for a more robust implementation and environment. A quick show of the DMTF board member companies: Broadcom, Cisco, Dell Technologies, Hewlett Packard Enterprise, Intel, Lenovo, NetApp, Positivo Technologica, and Verizon, which we are glad to see a user environment coming on board to help us keep our standards more usable. Just a quick plug on the DMTF in general. We do more than just Redfish, although Redfish has become clearly one of our more popular standards. SN BIOS is in every machine shipped in the past over a dozen years. It's got millions and millions of implementations. The widest standard that we have that nobody knows about. We've got this thing called PMCI, Platform Management Communication Infrastructure, which is how a lot of the Redfish data gets populated from information inside the box. There's this management controller transport, and there's a data model that goes with it that perform things like firmware update, monitoring and control, sensor data, power supplies, FRU, security is our latest thing, SPDM, security protocol and data model. We started with the USB authentication protocol to make sure we had something robust. It's a lot like TLS, but inside the box, so that we can set up secure environment for not just management traffic, but regular traffic too. We can do the key exchange, and that's why that standard is being adopted by folks like PCI, the PCI SIG, CXL, and others. So that's another piece of significant work. Traditionally, the DMTF has had the common information model, all the WebM, Smash, Dash, and efforts around that that preceded Redfish and other management standards. So what is Redfish? It's an industry standard software-defined management protocol for converged hybrid defined systems. It's produced by the DMTF. There's a Redfish forum. Currently, it's a RESTful interface using HTTPS as the transport with a JSON format in the body. Although, quite frankly, what we did was we separated the protocol from the data model so that we could map the data model to other schema languages, and we could map the protocol to other things. That's how we were able to do Redfish device enablement inside the box. So it's schema backed, but human readable. Really intended for GUIs as well as scripts and browsers, curl scripts. Both robust and human parsable. It's extensible, secure, interoperable. It uses HTTPS, so it's as secure as your connection to your bank account. It's accepted by ISO as ISO IEC 30115-2018, and we're updating those periodically to keep the ISO definition fresh. We've got a developer hub at redfish.dmtf.org. The initial release was in 2015, and we've come up with a trained model of doing releases approximately every 4 months. We might do 4 a year for a special need. The scope started out as meet comp with IPMI over LAN, but has grown drastically since then. while we're trying to do, everything inside of a server, whether that be rack mount bladed, HPC, future implementations, which has helped us evolve as the data center evolved to the cloud. So the current releases address really the rest of IT infrastructure beyond the server. We've been working with SNIA on Swordfish for 4 or 5 years now. We've worked with OCP to cover facilities, DSIM and ASHRAE as well. We worked with OCP for adoption inside the hardware management infrastructure with profiles. We adapted Yang models to cover some switching. We've worked with Gen Z and others to cover fabrics. In fact, we've extended the fabric model to cover Ethernet, and that's how we were able to do NVMe-OF. It's got a whole bunch of stuff in there as far as, EBGP and the rest of it. So it's a really kind of a step up from what you see in the IETF RFCs. We work within the DMTF for internal support. All the MCTP stuff I talked about earlier is how you can populate the Redfish data from the power supplies and sensors and memory and CPUs inside the box. We've got a host interface that's part of Redfish to replace IPMI KCS. And then there's the whole open source side of the effort, which is profiles and test tools and integrations with OpenStack and some of the provisioning things like Ansible. You can find that information out there. And the DMTF has a GitHub repo, which has a toolbox and little commandlets and emulators and all kinds of libraries to help you seed any work that you're trying to do. The timeline of the Redfish specification: we formed Redfish in 2014, came out with the first specification in 2015, and then evolved it over time. In 2016, we did the first fabric release, as well as the host interface. In 2017, we added composability, and we've added various levels of composability since that initial release. It really is where you can just point a manifest at Redfish and tell it to go compose your system based on your resource blocks. We've added profiling, server-side eventing. We had original eventing because somehow you've got to get notifications when things change. And then we added telemetry in 2018 as well, so that the metrics that are produced by the providers in Redfish can take advantage of the telemetry service to generate reports on a periodic basis, so you don't have to sit there and poll for them. We've added aggregation, and that is one of the open source efforts around ODIM has adopted that. We've got Ethernet fabrics as well in 2019, and that's kind of where really all the eBGP and neighbor and address pools and all that came out of the fabric model. And in 2020, we added Gen Z, and then we worked with SNIA and NVMe-OF support in Swordfish and came out with the first DSIM profiles in 2020. And then recently, we've released the SmartNIC efforts, as well as OAuth and some other parts as part of Redfish 2021.2. So, the Redfish ecosystem keeps growing. We've got more work coming with other alliance partners that are bringing changes in to work up the chain, as well as just traditional IT infrastructure. So it's been a really exciting half a decade and more as we work on Redfish and extend the support to the rest of the IT ecosystem and beyond. When it comes to the Redfish Resource Map, this is a simplified system. It really is kind of more like where we started than where we've gotten, because we've added fabrics and storage and composability and a whole bunch of other sandboxes off of the service route. But the service route really contained 3 original resources at first that were collections. So there were a collection of systems, chassis, and managers, where the computer systems were individual systems, whether they were physical or logical, made up of things on the data plane. Processors, storage, NICs, GPUs, power supplies. Oh, power supplies are on thermal. So anything on the data plane was put under systems. Anything in the physical view, things you could contain in sheet metal or air zones or racks or those kinds of things you'd put your hands on, those all went over into the chassis model. And of course, chassis are associated with systems, so that this power supply inside this chassis, or this thermal zone inside this chassis, or redundant power supplies, they apply power to this logical or physical computer system. And then all of this is managed by BMC or management sled or service even. It didn't have to be a physical implementation. So managers was kind of its own thing, which was more representation of the management plane instead of the data plane. And again, that BMC can manage chassis and systems. And as we added other things to it, storage and composability, and the manager could manage those services. So we set ourselves up for growth with the ability for multiple managers and multiple chassis and chassis inside of chassis, so that I could have cards in systems in racks in data centers, and all of those handling logical systems, however they were composed. But there were some root level services that were common to everything you were building out of data and management planes, things like tasks and jobs and sessions and accounts, eventing and registries, which are a way of showing you the messages that you could get from different systems. And then the schemas that define the resources inside the resource map. So we tried to build a complete ecosystem that any client, be they human or machine, would be able to find all the information they needed within a Redfish service to be able to manage everything within that service. So now I'm going to dive into the Redfish storage model. It's also known as local storage or server storage or Redfish storage. You hear talked about a lot the same way. We've really got 4 resources. There's storage, drive, volume, and controller, where storage is kind of the parent object that owns the storage subsystem. It contains the volumes and drives and storage controllers. And then the drive is the physical media. That may be over on a chassis. It may be underneath the storage, but that's where all the manufacturer information about the drive, part number, serial, the protocol that thing is capable of working over, any encryption capabilities on the drive, any control aspects like secure arrays, LED settings, blinking lights, that kind of thing. That's all in the drive. The volume is the logical construct used by the OS or hypervisor that contains the status of a volume which can span 1 or more drives. So you just post to the volume collection, the number of drives and pieces of drives and all the information about how big that volume should be and all that. And that's how you create the logical namespace or logical space. And then the controller represents the physical, or in the case of NVMe, logical controller infrastructure. Originally, that was intended to be like the array controller inside of a storage. We kind of deprecated that array inside the storage and created a storage object itself and created a new collection. And we broke that out really, in hindsight, we probably should have done it in the first place, but we really needed to break that out separately once NVMe came over. So it's really the same object. It's just also in a separate collection under storage. And that's shown on this chart, where I can have my system and my storage system hanging off of a computer system. Maybe that storage system in this case is an array. And that array could have controllers down here on the bottom, where I've got individual controllers. Those could be down there. And then I could have volumes up here. And so my drives hanging off my chassis, I can compose by posting to the volume system, compose a volume or namespace that spans 1 or more drives. And then we'll get into the controller information and what's all in that when we get into Swordfish a little bit later in other sessions. So note that the volumes are in collections off of the storage resource. Drives are in arrays off of the storage resource and optionally in the chassis. So that's a little bit different. And then the controllers can either be in an object in the storage or on their own, like you would expect them to be for NVMe. So watch out for that if you're writing client code. The Redfish fabric model was really invented for a couple of things, PCI switch fabrics and SAS kind of fabrics, but we've extended it to things like Gen Z and we're extending it to other networks as well. And so we ended up with this common fabric model that's used for Ethernet or other true fabrics. And that was what was adopted for the fabric side of NVMe OF. So the goal was to unify the representation of fabrics because management of the fabric is kind of the same no matter what fabric you've got. In fact, we're working with the Open Fabric Alliance to do that very thing. They've got some work going on around the Open Fabric Management Framework that, gosh, we've been working on for a couple of years now, getting it adopted and set up in the OFA to work with this Open Fabric Management Framework. So you can go over there and look for actual open source work that's going on around the management framework. But the thought is, whether that's an Ethernet-based framework or fabric or a Gen Z-based fabric or any other kind of fabric, they all kind of have the same thing, right? They've got switches, right? When switches have ports, and then you've kind of got endpoints, which are the things that you kind of plug the cable to at the end, which could be logical. It's not necessarily where the cable ends. Think of it as the end of the protocol stack, right? When that fabric, in the case of TCP/IP, it's kind of that TCP/IP, something's listening on that socket and getting data off, and that addressing part, that's still the logical endpoint. And then zones, because that's kind of my routing and default behavior. I can have a default route, a default zone where, and when an endpoint is created, what's its policy? Where does it sit? Who's it allowed to talk to? Those are the original objects. We just had fabric switches, ports, endpoints. Then we figured out zones. We added address pools because things like eBGP and DNS and DHCP, these were settings for the endpoints to get their information. Where do you get your address from? Who are you allowed to talk to by default? And so the address pools can have that kind of information in them. And then we were working on it originally for Gen Z, but became a very handy construct for NVMe-OF, was the concept of connection, which, okay, I've got my routing tables, but I've also got higher levels of software inside, that represent maybe a workload or a set of initiators and a set of targets. Who's allowed to talk to who? Are you allowed to read? Are you allowed to write? What other access bits are in there? And it's kind of come in handy for some other things like shared memory. So we took that model into the fabric model where you can create individual connections, either with individual endpoints, or you can make endpoint groups, which was something that Swordfish created, groups of endpoints and groups. So I don't have to tear down and set up my connections and modify them all the time, just because I want to add an initiator or add a target to a group. And so that's a handy construct that helps with scalability on the solution. So that was it for the fabric model. Now I'm going to get into Redfish device enablement just briefly, which is how do you fill in all that storage stuff without creating lockstep firmware dependency between my BMC and my storage firmware. And we hear a lot from customers that I want to separate my firmware dependencies. I don't want a fragile environment. How do you do that? So we came up with this thing called Redfish device enablement, which is just PLDM Redfish providers. The management controller can use, remember I talked about MCTP and PLDM early on as other work going on in the DMTF. We created a provider structure so that when the management controller is crawling out to all the devices, the management controller or storage controller can hold up its hand and say, hey, I support Redfish device enablement. And what that does is allow any controller that adheres to the standard without the BMC having any code in it at all, be able to export information about that controller. So these adapters are self-contained, self-describing. They've got their own dictionaries of how to translate the information into Redfish and into binary and back and forth. And so the BMC discovers all these devices, sets them up in the Redfish tree, and when a red request comes in for that part of the tree, it just turns it into binary, passes it down to the device. The device does all the Redfish command, sends it back to the BMC, and that decodes it back into JSON and spits it out the wire. So anything that works over PLDM or MCTP, like I2C and PCI VDM, those things can support Redfish device enablement. And really, this is a win-win. The integrators don't need to worry about working with every individual device vendor, and the device vendors don't have to worry about shopping their features and functions to every individual systems integrator out there. So it's really something that can help accelerate adoption of features and functions in the industry. So that's it for Redfish device enablement. Just one last shameless plug real quick. We've got a Redfish developer hub out there at redfish.dmtf.org. There's schema index and a schema guide and the specs and registries and all kinds of resources for a developer, but there's also educational material information for both developers and those just trying to become executives or CTOs, trying to become familiar with what Redfish does. And then there's a mock-up server out there where we're always adding more mock-ups, simple rack mount, bladed storage, bladed system, local storage, profiles out there, all kinds of stuff that we keep adding to the developer hub, plus the link to the community, the Redfish user forum, and the GitHub and YouTube videos as well. So we keep adding to our YouTube series. So go and subscribe to that channel as well. And as we add things, you'll be alerted. That's really it for my session today. Thank you very much for your time. Just want to remind you that Redfish, along with all the other work going on in the DMTF, plus our alliance partners like SNIA, we're really working to define interoperable software-defined hybrid IT management for servers, storage, networking, power, Coolix, everything in the IT infrastructure. And we're working our way up the food chain. And all of this is plumbed with the mechanisms inside the box, which are standards largely from DMTF, but also our alliance partner organizations. And we're working to enable that platform to have a zero trust model. So making sure it's secure going forward. So thank you for your time, and I hope you enjoyed the session.